Okay, ma'am. You see this problem? Okay, this problem comes under relative frequency. Okay, so probability definition using relative frequency. Here we have a box with 80 registers. Okay, each having the same size and same shape. Okay, in these 80 registers, okay, we have 18 resistors of 10 ohm and 12 resistors of 22 ohm, 33 resistors of 27 ohm, 17 resistors of 47 ohm. These are the four varieties we have. So we have 18 resistors of 10 ohms, 12 resistors of 22 ohms, 33 resistors of 27 ohms, and 17 of 47 ohms. Okay. Now, if the experiment is randomly drawn out one resistor from the box with each one being equally likely be drawn, then relative frequency suggests that the following probabilities may reasonably be assumed. Okay, what is the probability of drawing 10 ohm resistor will be? How many 10 ohm resistors are there? 18 divided by total number of resistors, 18, 80. So the probability of drawing 10 ohm is 18 by 80. Similarly, probability of drawing 22 ohm will be what? How many resistors we have? 22. 12 no? 12 by 80. Similarly, probability of drawing 27 ohm will be 33 by 80. Probability of drawing 47 ohm will be 17 by 80. Okay. So this is the probability we get when we find the probability by using relative frequency. Okay. Now we assume that all these resistors are distinct and mutually exclusive. Both individually and by type have only four types, and some resistor must be chosen. Sum of the probability of all four events must be equal to 1. So if you add all this, 1 by 80 plus 12 by 80 plus 33 by 80 plus 17 by 80, what is the value you get? It will be equal to 1. Okay. So next, assume that 22 ohm is drawn from the box and not replaced. See here, 22 ohm is drawn from the box and not replaced. So if you have not replaced, then how many resistors we will be having? 75, 79 resistors we have. Okay, 22 ohm we have already drawn and it is not replaced. Now we will be having 79 resistors. Is it clear? Understood, students? Okay,
Yes,
so
yes, ma'am.
now if you have only 79 resistors, now what is the probability of drawing 10 ohm resistor? How many resistors we have now? We have only 79 resistors. After drawing, we have only 79. Now, what is the probability of drawing 10 ohm resistor? Assuming that 22 is drawn already. 22 ohm is drawn already. Now, what is the probability? It is 18 by 79. Now, what is the probability of drawing 22 ohm resistor? Assuming that 22 ohm is drawn already. Now, before the case, how many 22 ohm resistors are there? 12. Now, we have drawn already one 22 ohm resistors. Now, total number of 22 ohm resistors will be 11 only. So, it is 11 by now the after drawing 22 ohm resistors, number of resistors in the box will be 79. So it is 11 by 79. Similarly, drawing 27 ohm resistors, assuming that 22 ohm is drawn already, will be equal to 33 by 79. Okay. Similarly, 47, because we have not changed the total number of 47 resistors, so numerator will be same, denominator will be reduced by 1 because we have already drawn 22 ohm resistors and we have not replaced. Okay, so that is why it is given like this. So this way of notation, you see here in this previous case, we have used this way of notation. No, P of 10 ohm already given that 22 is drawn already. Okay, second is drawn or known as condition on outcome of first drawing. There is a condition on outcome of first drawing. Yes or no? Okay, so this reasoning is readily extended to other drawings in sequence without replacement. Okay, is it clear? So what is this? Is this way of representation is called condition on outcome of first drawing. The second drawing or now condition on outcome of first drawing. This is called conditional probability. Anyway, we'll be discussing that in detail in the coming topic. Okay. Any doubts, students, here? Is it clear? Understood?
Yes, ma'am. Yes, ma'am.
Thank you, ma'am. Only one student voice I can hear every time. I think Chandana, no? Chandana, you will be telling me every time? Okay. See here, now we'll discuss what is joint and conditional probability. Okay. So for example, some events are not mutually exclusive because of no common elements in the sample space. If two events does not have common elements, they are not, sorry, if they have common elements, they are not called mutually exclusive. Okay, if they have common elements, then those events are called not mutually exclusive. If they do not have common elements, they are called mutually exclusive. Yes or no? These elements corresponds to simultaneous or joint occurrence of non-exclusive events. Okay, so because of this common elements, so whichever elements is common to both the events are occurring, because of that we will be having joint occurrence of non-mutual, non-exclusive events. Okay, so for two events A and B, common elements form the event A intersection B. A intersection B we use to describe the common elements between A and B. So if A intersection B is not equal to null set, if A intersection B is not equal to null set, then those two events are not mutually exclusive. Okay. So now we'll define what is joint probability. Joint probability is called the probability of, okay. So it is called the probability of, uh, here, it is the probability of, so it is the probability of A intersection B. Okay. So this is called joint probability. Okay. So the from the Venn diagram, so if you draw the Venn diagram, can you tell me what is A intersection B can be written as? A intersection B is only this part of the diagram. Okay. So only this part. This is the A intersection B. Yes or no? So from A intersection B is nothing but what? Probability of A. Okay. So this is the probability of A plus probability of B. Okay. If you draw probability of B, what happens? This intersection part included two times. Probability of B. Okay. Minus probability of A union B. Okay. So A union B will give us, okay, A union B will give only this part. This is the part A union B will give us. Okay. So now probability of A plus probability of B minus probability of A union B gives this intersection part. Okay. So from this probability of A intersection B is equal to, it is given like this. This is defined from the Venn diagram. Okay. So using Venn diagram, we can show that probability of A intersection B. This also we have already discussed, no? In when we have discussed the proof of identities, where we have discussed this, probability of A intersection B is equal to probability of A plus probability of B minus probability of A union B. Okay. So if a sample space consists of two events A and B which are not mutually exclusive, if these are not mutually exclusive, there is a chance of getting A intersection B value. Okay, so we will be having some values common to both A and B. Then the probability of these events occurring jointly or simultaneously is called joint probability. Okay, so if two events are not mutually exclusive, then probability of these events occurring jointly or simultaneously is called joint probability. Okay. So for example, you have event A. Event A is given as, when you throw a die, event A is given as having the value 2, 4, 6. These are the values of event A. So for example, event B will be given as, okay, it is given as 1, 2, 3, 1, 2, 3. Okay. Now, say if we get the value 2, if you get the outcome as 2, then we say that the A is occurred and B is also occurred because 2 is present in both A and B. Yes or no? The value 2 is present in both A and B. So if you are getting outcome as 2, okay, if any one of this outcome you will be getting as output, then we can say that event A is occurred. Similarly, in the event B, if any one of this is occurred, we can say that event B is occurred. If you are getting 2 as outcome, then we say that both event A is occurred and event B is also occurred. So that we can say that these two events are jointly occurring. That is why the occurring of these events jointly or simultaneously is called joint probability. Okay. So it is also defined like this. Joint probability of events A and B is equal to relative frequency of joint occurrence. Okay. So we have to find out what is the relative frequency of joint occurrence. Okay. So if the experiment is repeated, what is relative frequency? Relative frequency of, for example, probability of A can be obtained by using relative frequency. Can you tell me, anybody? How do you define the probability using relative frequency? Anybody, ma? Hello? How do you define probability of A by using relative frequency? I have written here. Can you see this? So we will be conducting the experiment n number of times and checking for how many times the event A occurred. Okay. Then probability of A can be written as the limit n tends to infinity, number of times event A occurred divided by n. Yes or no? So the same procedure we use to find out the joint probability. So here the experiment is conducted n number of times, and we will be checking how many times the joint occurrence of events is occurred. Okay. So using that, the joint probability is defined like this. The joint probability is given as probability of A intersection B is equal to, okay, probability of A intersection B is equal to the limit n tends to infinity. So how many times? Number of times the event A and B occurred. Number of times these two events occurred together divided by number of times the experiment is conducted. Okay. Using that, we will be defining what is joint probability. Okay. So from understood, students, any doubts here? What is joint probability? So joint probability is defined by using relative frequency also. That is, probability of A intersection B is equal to limit n tends to infinity, number of times both the events occur together divided by number of times the experiment is conducted. Is it clear, students? Any doubts? Hello, students, please respond.
No, ma'am. No, ma'am.
So from Venn diagram, we have shown that probability of A intersection B is equal to probability of A plus probability of B minus probability of A union B. Then what is probability of A union B? Is given as probability of A plus probability of B minus probability of A intersection B. Okay. So, and if these two are, say, if A intersection B is not equal to 0, these two are not mutually exclusive. If it is equal to 0, these two are mutually exclusive. If it is not equal to 0, what is probability of A union B? A union B will be having the value greater than or equal to probability of A plus probability of B. Okay. Similarly, if event A and B are mutually exclusive, if event A and B are mutually exclusive, then there will be no common elements between A and B. Can you tell me what is probability of A union B now? Can you tell me what is probability of A union B now? Hello, students. What is given? A intersection B. A intersection B is equal to, sorry, A intersection B is equal to null set. Then can you tell me what is probability of A union B?
Sum of individual properties, P probabilities.
Very good. It is equal to probability of A plus Probability of A.
Probability of A plus probability of B.
Very good. So, if two events are mutually exclusive, then probability of A union B will be equal to probability of A plus probability of B. Is it clear, students? Any doubts?
Yes,
here?